Okay, so in this video, we're going to go through several more examples. But here we want to write an equation given 2 points. If you're given 2 points through which a line passes, you can use them to find the slope first. We already talked about how to do that in Chapter 3. Then just do the same steps we did in Example 1 to write the equation. So here you're given 2 points. If you know 2 points, you can find the slope. And then if you have the slope and just pick one of those points, you can do what we did in the previous example and get the equation of the line. So write an equation of the line that passes through each pair of points. We'll do 2 examples. So 3, 1 and 2, 4. So first you find the slope. So remember, the slope formula is y2 minus y1 divided by x2 minus x1. Remember, your x1 and y1 are the x and y from your first point, and your x2 and y2 are the x and y from your second point. So you plug those in, and you get 4 minus 1 over 2 minus 3, which is 3 over negative 1, which simplifies to negative 3. Now I know the slope. So the second step is to use either of the 2 points they give you and the slope that you just found. It actually doesn't matter which point you use. Most people use the first one. I use the second one here just to show you that it works. But like I said, it doesn't matter which point you use. If one seems to be easier to plug in, use that one. So we're going to plug in 2 and 4 for x and y, and negative 3 for the slope, and solve for b. So you get 4 equals negative 6 plus b. Add 6 to both sides, or subtract the negative 6, and you get b equals 10. Now I know the slope and the y-intercept, so slope-intercept form, I plug in negative 3 for the slope, 10 for the y-intercept, and my equation is y equals negative 3x plus 10. All right, let's do the same type of problem with these 2 points. Again, you find the slope first. So use negative 4, negative 2 is your x1, y1, and negative 5, negative 6 is your x2, y2. Plug those in. Now be careful with the signs. You're subtracting negatives here, so it's going to be like 6 plus negative 6 plus 2, negative 5 plus 4. So you get negative 4 over negative 1, which simplifies to just positive 4. Then the second step is to use either point. Now in this case, we used the first point. It doesn't matter. You can use either one. And the slope that you just found in the y-intercept or the slope-intercept formula, and solve for b. So if I simplify, you get negative 2 equals negative 16 plus b. Subtract the negative 16 or add 16 to both sides, same thing. And you get b equals 14. Then you know the slope. You know the slope is 4, the y-intercept is 14. Plug those into the slope-intercept formula, and that is your answer. Okay, make sure you go the whole way. Don't just find the slope and stop. Don't just find the y-intercept and stop. Make sure you write the equation because that's what it asked. All right, here's your turn. Go ahead and pause the video and hit play when you're ready. All right, we're back. So first we're going to get the slope. So that's negative 8 minus 12 over 4 minus negative 1. So that's negative 20 over 5, which is negative 4. So slope-intercept formula is y equals mx plus b. I'm going to use the first point, so 12 equals negative 4 times 1, or excuse me, negative 4 times negative 1 plus b. So you'd have 12 equals 4 plus b. Subtract 4, and you have b equals 8. So your equation is y equals negative 4x plus 8. The second one, your slope is going to be 0 minus negative 8, negative 7 minus 5, which is going to give you 8 over negative 12. Okay, which reduces to negative 2/3. So if I have y equals mx plus b, I have y, I'm going to use the second point. 0 equals the slope negative 2/3 times x, which is negative 7, plus b. Now to multiply those, I would put the negative 7 over 1 and multiply fractions. So I'd have 0 equals negative 14 thirds plus b. Add 14 thirds to both sides. You have b equals 14 thirds, which is fine. You're allowed to have fractions. And then our equation would be y equals negative 2 thirds x plus 14 thirds. And there's our answer. Okay? All right. So in mathematics, a constraint is a condition that a solution must satisfy. Equations can be viewed as constraints in a problem situation, and then the solutions of the equation meet the constraints of the problem. So how does that work out in an example? So the table here is going to show the number of domestic flights in the US from 2004 to 2008. Write an equation that could be used to predict the number of flights if it continues to decrease at the same rate. Okay, so you know the number of flights from 2004 to 2008. So you could think of those as all of these as ordered pairs. If I let x represent the year and y represent the flights, then I could think of those as x comma y. And then I'm going to let x just be the number of years after 2000 to make the problem a little bit simpler. Okay, so write an equation of the line that passes through the first point and the last point. So this point would be 4 comma 9.97, and this would be 8 comma 9.37. Okay, so I know 2 points. I don't know the y-intercept. They haven't told me the slope, so I got to figure out the slope. So plug those values into the slope formula, and now we get negative 0.6 over 4. So you could use your calculator and find that to be negative 0.15. And then use the first or the second point. We're going to use the second point to find the y-intercept. So slope-intercept form, plug in the x and y value from the point, the slope that we just found. Simplify, so multiply this. Add 1.2 to both sides, and you get b. So here's the equation of the line, which is y equals negative 0.15x plus 10.57. Okay, so that's the equation of the line. So we can check our result by using the coordinates of the other point. So I can plug in the other point that I used to find the slope in the equation, and it should work out. Okay, you have to use one of the 2 points that you use to get the slope to do your check. Don't use the other points from the table. All right. So in addition to his weekly salary, Ethan is paid $16 per delivery. Last week he made 5 deliveries. His total pay was $215. Write a linear equation to find Ethan's total weekly pay, T, if he makes D deliveries. So in general, you have y equals mx plus b. So in our situation, it's going to be T equals the slope times D plus b. Okay. We know that his rate is $16 per delivery, that he made 5 deliveries, and his total pay was $215. So we know that the slope is 16, the deliveries is 5, and the total pay is $215. What didn't they tell us? They didn't tell us his y-intercept, which would be his weekly salary, because it says in addition to his weekly salary, so that's how much he starts with if he doesn't make any deliveries. Okay, so plug in what you know. 215 equals 16 times 5 plus b. 215 equals 80 plus b. Subtract 80, and you get b equals 135. So our equation is T equals 16D plus 135. All right, pretty straightforward there. Okay, this is our last problem here. You can use a linear equation to make predictions about values that are beyond the range of the data. This is called linear extrapolation. Like you assume that the line keeps going and you can make predictions about what goes on after that. This just accidentally came up. So Let's estimate the number of domestic flights in 2020. So this is the same table from example number 3. So what I can do is take the equation that I developed from example number 3, and if I want to go to the year 2020, I would plug 20 into that equation, and it's going to be 5.57 million flights. So let's do the same thing with Ethan. Use the equation from number 3 of our previous year turn problem to predict how much money Ethan will earn in a week if he makes 8 deliveries. Go ahead and pause the video. All right, we're back. So if he makes 8 deliveries, that's the same as plugging in 8 for D. So T equals 16 times 8 plus 135. So if I do 16 times 8, that's going to give me 128 plus 135, and that means 263. So since it's in the context of a problem, that means that Ethan will earn $263 if he makes 8 deliveries. Okay, make sure you put the units and explain what the answer is if it's in the context of a situation. All right, guys, that's it for this section. Please continue on to your assignment. Reach out to me if you have any questions, and talk to you later. Take care.